Now some multiplication and division with expressions that contain radicals. Here I want to multiply 2 square root 3 times 5 square root 7. I'm going to apply the commutative property and associative properties of multiplication to write this as 2 times 5 times square root 3 times square root 7. So I group the numbers that are outside the radical together, and I group the numbers with radicals together. That's the commutative and associative properties. Now 2 times 5 is 10, and square root 3 times square root 7 is square root 21. So the point of this is, when it's all multiplication, I can multiply the numbers that are outside the radical, and I can multiply the numbers that are inside the radical. But I can't multiply something outside a radical with something inside a radical. Let's try another problem. Square root 3 times the quantity 2 square root 2 plus square root 3. Distributive property, I'll multiply square root 3 times this. I get square root 3 times 2 square root 2 plus, that's that plus sign, square root 3 times square root 3. Now, here I have 2. Square root 3 times square root 2 is square root 6. I multiply the numbers that are under the radical together, plus square root 3 times square root 3 is just simply 3. I could write it as square root 9 if I want to show another step, and then the square root of 9 is 3. So you want to check a problem like this out real carefully and see that I'm doing the same type of thing that I did with problem 1, multiplying the numbers outside the radical and multiplying the numbers underneath the radical. How about square root x plus 3 quantity squared? Remember that this exponent 2 means that this is square root x plus 3 times square root x plus 3. Now if I use something like my FOIL method, I have square root x times square root x, that's x, assuming that x is a positive number. Square root x times 3 is 3 square root x. 3 times square root x is 3 square root x. And 3 times 3 is 9. So I see I have two similar radicals right here. So I have x plus 3 square root x plus 3 square root x is 6 square root x plus 9. So I multiply these, or I expand this expression right here in much the same way that I would expand two polynomials. Multiplying two binomials, I multiply each term here with each term here. Check to see that these are the 4 terms that you get, and then these two being similar add up to 6 square root x. Let's try some more. Square root 5 minus 2 times square root 5 plus 2. Let's just multiply like we did in the previous problem. Square root 5 times square root 5 is 5. Square root 5 times 2 is 2 square root 5. Negative 2 times square root 5 is negative 2 square root 5. And then negative 2 times positive 2 is negative 4. So I have 5 plus these two add up to 0 minus 4. So I end up with 1. Now this will always happen in this situation. That is, I'll multiply two expressions that have this form. If either one of them contains radicals, my answer will not contain any radicals, because this times this always results in the difference of two squares. The first term squared, which will be 5, minus the last term squared, which will be 4. My last problem is a division problem. I have square root 3 divided by square root 5 minus square root 2. To do this division, it's the same as what we call rationalizing the denominator. So I want to take the denominator I have and get rid of the radicals in it. To do that, I multiply by square root 5 plus square root 2, because when I multiply these two things together, I'm going to get the difference of two squares. Whatever I do to the denominator, I have to do to the numerator also. So that's the number 1. Multiplying this expression by the number 1 is not going to change its value. Now, square root 3 times square root 5 is square root 15. Plus square root 3 times square root 2 is square root 6. In the denominator, I have square root 5 times square root 5, which is 5. Inside is minus square root 10. Outside is minus square root 10 plus square root 10. That adds up to 0. And then I have minus square root 2 times square root 2, which is just 2. So I end up with square root 15 plus square root 6, all divided by 3. And that is as simple as I can get with this expression right here in division. So dividing square root 3 by the quantity square root 5 minus square root 2 gives us this expression right here.